Okay, 2.4 is about linear inequalities. So a linear inequality, an inequality is when you say something needs to be less than or greater than or equal to. Okay, so it's where you have the inequality signs that look like, oops, that's an eraser, not a pen. You get a pen here. So we have this. Okay, so those are what inequalities are. Now, an inequality is used in real life a lot, actually. There's certain times that you have to be above or below certain numbers. So for instance, let's say that you get a job. You get this job and you get paid $600 a month, but then on top of that, you get a 20% commission. So what amount of sales would you have to do to make at least $1,500 a month to pay your mortgage? Okay, so like as you have maxes, amounts that you need to be over, or maybe it says, you know, that you have to make, that you need a value under a certain amount of money. So maybe like you're using a certain amount of electricity in your home, what you need to use the amount under to be so that your payment is under a certain amount. Okay, so there's certain things that you can expect inequalities to be in real life. Okay, now when you've used inequalities in the past, whoa, you've probably seen them written like this. Let me see. A lot of times we're going to start out with writing them on a number line. So you can kind of see on a number line, let's say you had like x is greater than 2. Okay, it's greater than, so it's an open circle, and it's greater than, so you would move up the number line. Okay. So this would be a number line of how you probably have seen it. In the book, it's going to do it slightly different. It's still the same. It's going to be the expecting or representing, I mean, the same thing. So if you have 2, 3. So here now, if you're asking for where x is greater than 2, they're going to change the notation a little bit and say x where x is greater than 2. So this notation, this slide just means where or when. So x when x is greater than 2. And then this notation just means it's that set of numbers. Okay, now when you make the a notation of writing out what the answer would be, an interval notation, if it's greater than and it doesn't have the equal with it, it's a bracket, it's a rounded parenthesis. It's a bracket if it has equal to. So here, this would look like this parenthesis and then moving forward this way. Okay, now the reason that this makes it easier is now when you go to write your interval notation, you already know that this is going to be a parenthesis. So it would go from 2 to infinity. Okay, so now let's look at another one. If I want to represent x is less than or equal to 2. Actually, let's do, let's do 3 just to be fancy with something different here. Okay, so then here, if you want x to be less than or equal to 3, normally what you guys have seen is you would do a solid circle to say that that 3 is included, and then you would draw the line down to less than. Okay, so in this new notation that we're going to be dealing with, we would say x where x is less than or equal to 3 and put it in set notation. So now we would take our point of 3, and I'm going to now take, because 3 is included, instead of doing a hollow circle, we would do a bracket. Okay, and this hard-sided bracket means that that 3 is included. The parenthesis means that it's not included. So then once again, it makes it here. Now remember, parenthesis always around infinity, because infinity is not a real number, and so you can never get there, right? It's a place that you're going to. So here, and then on this side, it would go all the way up to 3, which would have a bracket on it. So this bracket and these parentheses help you with writing your interval notation. Okay. So let's see the next thing. Let's try one that's a little bit more tricky. Let's say where we want x to be in between -1 and 5. Okay, so normally you'd have your 1 to 5, and you would say, okay, this is included. The -1 is included, but x is greater than it. And this 5 is not included. Oh, so sorry, this is included. and this one is not included. And x is in between those two numbers because it's greater than -1, but it also has to be less than 5. Okay, so you kind of like draw it in like that. Okay, so now let's write it in this notation. X, where -1 is less than or equal to x, which is less than 5. And you have it in your set notation. Now when you draw it on here, you'd have your -1, 0, 1, 2, 3, 4, 5. And this what you would have where -1 is not included, or is included, sorry. So you have your bracket. And here where 5 is not included, you would have your parenthesis, and it would be in between. So you can see that these are very similar to what you've done in the past, but this is the way the book is going to write it. Okay, so the next thing that we need to do is to be able to write down what we're getting here, but also to solve and get ready to write it down. So if it's in this form, we can't really tell what x is greater than or less than. So we need to start solving it with the other skills that we used in our last sections, and get all the x's on one side, all the constants on the other, and solve for x. So here, to get the 6 over to this side, I need to subtract 6x. Okay, for some of these processes, you're going to be able to just treat it like you would an equals. You just need to keep this symbol in here. So with subtracting, adding, you can leave it. Be careful not to swap sides or anything like that. It needs to make sure that this is pointing towards this side every time. But this would say that x is less than 1. So the solution would be x, where x is less than 1. And that would be the set of numbers. If you needed to write it, you would have 1, and x is less than 1, not including 1, so you'd have this parenthesis going down, which means that your interval notation would be from -infinity to 1. Okay, so it makes it really easy. So adding and subtracting never switches the sign. Adding and subtracting, just you move forward the same. Multiplying and dividing. If you are multiplying or dividing by a positive number, it does not affect it. So for instance, if you have 5, 6x equals, or sorry, is greater than or equal to 5. So here, I can choose to just multiply by 6 on both sides to get rid of this denominator here. So the 6's will cancel. I'm left with 5x is greater than or equal to 30. And then here I'm going to now divide both sides by 5. So here I'll get x is greater than or equal to 6. Okay, so here in this example, I now multiplied, I divided, and neither of those things affected it because I multiplied and divided by positive numbers. So what happens is that now if I multiply or divide by a negative number, every time you multiply or divide by a negative number, you need to switch your sign. So here, if I have -3x is less than or equal to 9. I go to solve this problem, and I'm going to divide both sides by -3. Now remember, dividing by a -3 and subtracting something are two different things. Make sure you know which one you're doing. If you are multiplying or dividing by a negative number, you need to switch the sign. So first things first, this sign has to switch. So here I end up with x is equal to 9 divided by -3, which is -3. Okay, so that sign got switched. Let's do one here where if I have sometimes I make them up and then they don't come out very pretty. We'll go into a little bit harder one for the next example, okay? So we have one very, very important thing to remember. If you multiply or divide by a negative number, you must switch your inequality, okay? Now, the more important thing to remember that I see all the time, if you subtract a number, it does not flip the sign. It's only if you multiply or divide by a negative number. Okay, let's quickly go through two examples of a little bit harder problems. You're going to use the same steps that we used in solving our linear equations to solve these. And the only thing you have to remember is switch the sign if you multiply or divide by a negative number. If you multiply or divide by a positive number, you don't switch it. If you subtract, you do not switch it. It's only if you multiply or divide by a negative number. Okay, so first thing I'm going to do is I need to be able to move around things to get all of my like terms on one side. So I'm going to first get rid of parentheses here. So I'm going to distribute my 5 into the parentheses, and I get 5x plus 20. It does not affect my inequality. This one also needs to be distributed in so that I have fluid terms that I can move around. Okay, I can't move them around when they're like this because this multiplication messes with things. So I need all addition and subtraction so I can move things back and forth. Okay, next I'm going to subtract the 8x from both sides. And I do not switch the sign because that's subtracting, not multiplying by a negative number. Okay, so I subtracted the 8x. So I have 5 minus 8 gives me a negative 3x plus 3. And over here, they cancel each other, and I'm left with just 12. Okay, now I'm going to subtract 2 from both sides. Once again, I'm subtracting, not multiplying by a negative number, and so it stays the same way. So now I have negative 3x on this side, and over here I'm left with 10. And then here, now I'm going to divide by a negative 3. I'm dividing by a negative number, so the first thing that happens is I switch the sign. This cancels out, I'm left with x, and over here I am left with a negative 10 over 3. Okay, so you need to be really careful that you're switching it when you're supposed to and not switching it when you're not supposed to. Okay, here, when we remember the best thing to do when you solve, when you want to get rid of denominators, is to multiply everything by the LCD. So here I'm going to take and multiply everything by both sides of the equation by the least common denominator. So 7 is a prime number, 3 is a prime number, so we're going to have to multiply both by 21. Okay, but what happens is when we multiply this by 21, the 3 is going to cancel, and we're left with 7 times 1 minus 2x. The way that I like to think of this is the same thing as 3 times 7. So when you're looking at that, those 3's cancel here, and this will be 3 times 7 that you're multiplying by this whole thing. So the 7's will cancel here. So I'll get 3 times 3x plus 7, because the 7 canceled out on the bottom, and then over here I'm going to get 21. Okay, now we move back to this side, this process where we're getting rid of the parentheses next. I'll get 7 minus 14x plus 9x plus 21 is greater than 21. And then I can start moving things to the same side to combine like terms. First, we can just combine this negative 14 and the 9. So negative 14 and the 9 is going to give us a negative 5. So my 7 here hasn't switched the sign yet because I have not multiplied divided by a negative. Then here I'm going to subtract the 21, as I could combine like terms. Either way is going to give me the same thing. Subtract 21 from both sides, and that gives me over here a 0. Then subtract the 7. Now remember, subtracting 7 is not multiplying or dividing by a negative. It's subtracting, so it doesn't switch. So we're left with this here with a negative 7. Now I'm going to divide by a negative number. So this sign, the first thing that has to happen is it has to switch around. And we get x is less than. Negative divided by negative becomes a positive. And x is less than 7/5. A reminder, do not change your answers to mixed numbers. I want them as improper fractions. Okay, so keep it with a large number on top all the time with these.